This is mine.
Hi. Hello. Well, hello. Oh, it's just crap. Come on, try again. Hi. Hi. Oh, thank you very much. Very good stuff. Hi, Mark.
Hi, Josh.
We're going to go through a lot of stuff today, like we always do. We're going to go through a lot of stuff. So if you have questions, comments, feedback, whatever, we encourage you to reach out to us. We're on the internet. We're on Twitter. We have email. We're happy to answer questions. How many of you are on Twitter? Twitter? Okay. Well, the rest of you get on it. It's a great place to be. It's with the new IRC. It's where all the developers that work on the open source that drives your business are. And if you want to engage, we're happy to engage. What about email? Email. How many of you are using email? Anybody? No? Okay, very good. Good stuff. We also have code. The code for what we're going to talk about is online as usual. So you'll find that GitHub repository there in the bottom of the of our slide.
Look,
right?
Look, it's a Mac. It does this.
7 minutes. So the code is there for your own reference, for your own notification for later. So grab that for your own reference. Now, we're going to talk about Reactive Spring today, right? And we have a sort of a long journey to go through before we can even begin to talk about what we're about to talk about. We have, we have an interesting situation. At Pivotal, we on the Spring team have seen a lot of people who are moving to this new architecture. We talk about microservices, right? And this isn't a new idea. This idea of microservices, what we're trying to do, what we're trying to help organizations do, is to better decompose their applications into smaller batches of work, smaller units of work that small groups of people can work on. And that decomposition is a natural thing to do. It's a natural, huh?
Nothing.
Oh, it's a natural.
I'm just poison ready.
Oh, oh, yes. Wait.
We forget
Pause.
again.
I didn't mean to forget.
We skipped the most important part, okay? Because if we don't prove that we were here and not just doing work, and not just soaking up the good barbecue, we don't get paid. So that's kind of
okay. Ready, steady. Say open source. Wait, get your head.
All right. Yes, try it again. Open source.
Oh,
all right. Surely one of those will turn out.
Right on. So let's see. So we see a lot of organizations moving to this new architecture, this brave new architecture. They're trying to go faster. They're trying to eke out more organizational performance. So they move to this architecture that allows us to decompose teams, larger teams into smaller teams so that they can focus on smaller batches of work. And this architecture has some logical consequences. When you move to this architecture, you invite the complexity of building a distributed system. And we've talked about that. I'm sure you've probably at this point heard about Spring Cloud and seen approaches to solving some of this complexity. One place where we've not really had a sort of a strong solution, really, in this industry in general, is around large amounts of input and output. If you're dealing with lots of services, you've got lots of small services talking to each other, you've invited now the complexities of moving data around the wire, around the network. And that input and output, that I/O becomes very expensive. It becomes very inefficient in a traditional sort of blocking synchronous architecture. So what we're looking for is a way to go faster, right? To be able to send data as fast as possible, but then to reuse threads as input and output is stalled, or if it's blocking, or if it's doing something. I want to be able to reuse the thread that's involved in that. So this isn't a new idea, not even close, right? If you look at the basic input and output primitives for your average operating system 20 years ago, the network I/O layer for these different operating systems tends to be asynchronous by default, right? They are asynchronous by default because the reality of the situation is that input and output is not going to be continuous. There are going to be gaps, there's going to be latency, etc. And so there's no point in blocking while we're waiting for that input and output. Furthermore, we can also, we can simplify things by treating asynchronous like synchronous, but it's very hard to treat something that is synchronous like asynchronous. So operating systems by default think about the world as being asynchronous sort of sinks and sources of data. It's only in the JDK, in JDK 1.0, for simplicity, we had the input stream and the output stream, a synchronous blocking abstraction, which removes us from the power of this underlying primitive, right? So we've been looking for ways to make that, to support that kind of input and output stream, that kind of input and output, the kind of asynchronous event-driven input and output that we can do in the lower-level operating systems. JDK 1.4 introduced NIO. NIO brought the idea of a channel, and channels got us some of the way there. Certainly, JDK 1.7 gave us NIO2. This got us some of the way there as well. But that's not really enough, is it? It's not really enough. I don't see you writing web applications and doing database applications in terms of input streams and output streams, why would you any sooner write your web applications in terms of channels, right? We work at higher levels. We think about things at a higher computational level. So while we've got a paradigm for doing input and output asynchronously at the lower level of the stack, we don't really have that support at the higher levels of the stack. Different companies in the ecosystem have tried to address this. We've seen a lot of really innovative work done in the last 10 years. I think sort of the 800-pound gorilla was certainly the Microsoft research. They had the RX extensions for .NET, and that of course begat RX Java from Netflix. You see Lightbend, which is a company that was born as TypeSafe. They have a project called Akka that serves this space as well. Coming out of Spring Source at VMware was a project called Vertex. That's now at Red Hat, right? And of course, we had Project Reactor from VMware as well, before Vertex. And Reactor is what we on the Spring team have been working on. And these different projects all sort of aim at the same kind of problem space, which is I need higher order computational primitives to be able to think about my systems and my applications, to be able to work with this bit of work with this idea of data that's asynchronous and eventual. We're trying to fill in a gap that we don't have in the basic JDK. If you think about the way we model software today, if you think about the way you have to write a system that deals with a single synchronous value, maybe you're returning that from a method, for example, that's pretty easy to do, right? I would say, my method is called foo and it returns t, or t could be string, for example. No problem. What about if I have a method that returns a synchronous but large amount of values, not just a single record, right? Well, we talk about collections. We can say I have a method that returns a collection of t, a collection of strings. We even have, to be fair, as of JDK 8, we even have the ability to talk about a single value that we get asynchronously. Right? Well, actually, starting from JDK 5, but really, for it to be useful, we talk about JDK 8, we have the completable future. The completable future gives us a way to talk about a value that we will be able to process, but that we don't have just yet. Right? And it'll give us a notification. It'll give us a callback. That's the interesting sort of distinguishing feature of a completable future versus a future. What we're missing, what we have no real good story for, is this idea of I have multiple values that I want to process asynchronously, eventually. And so that's where a lot of these different projects have tried to fill in the gaps. And a lot of the work that we've done in these different projects have there's a lot of convergence there, a lot of common ideas. And so that actually led to what's called the Reactive Streams initiative. This is a sort of de facto standard. It's a collaboration between the companies, the aforementioned companies like Pivotal, like Red Hat, like Netflix, and like Lightbend, TypeSafe, to define that basic thing, that very, very simple concept, that thing that we need to describe, which is something that produces a value, a potentially unlimited set of values, asynchronously, eventually. And the Reactive Streams initiative does a great job there. It has 4 interfaces, 4 very simple interfaces. The first and most important is publisher. A publisher produces values. Doesn't tell you how many, it just knows that we just know that it does. And you can subscribe as a subscriber to those values, and in so doing, you get a subscription. There's 3 interfaces already: subscriber, subscription, and publisher. If you are a component that both produces values as a publisher and subscribes to other values being emitted, then you are a processor, and that is our 4th interface. That's it. That is the sum total of all of the work that we've done in the Reactive Streams initiative. It describes the basic component model, the basic, missing sort of gap there that we need to be able to use. And in fact, that work is so useful that it's now been sort of surfaced in JDK 9 as Java util concurrent flow. Right? That basic work has inspired that there. But even there, we're not really home free, are we? Even with the Reactive Streams initiative, we're still missing support at the higher levels. Right? A publisher is useful, but not the most useful thing, right? I still want to be able to process these values. I want to be able to stream them, to filter them, to transform them, to work with them in the same way that I can, for example, JDK streams, JDK 8 streams. I have no processing capabilities. I have no operators with which I can sort of manipulate these streams of values, to gate them, to combine them, compose them, etc. So we need support there. And even if we have that, we still don't have a foundation for building our applications, because just that support in of itself is not inherently useful. We need support for doing data access, right, in a way that takes advantage of that asynchronicity at the lowest levels of the input and output stack. We need support for building web applications, including addressing security, right? We need support for doing all the things that we do in our traditional application stack, but with these sort of asynchronous primitives in mind. And so that's what we're going to talk about today, is what we have done in the Spring project and in the Spring ecosystem to support these goals, starting with, of course, Spring 5, a release of Spring that is so awesome that it will come in the summer. Spring 5 is the baseline for everything we're going to talk about today. It is not yet GA. The last I heard, it was end of September. Is that still roughly true? Yeah. And then that will be the baseline for everything else that you'll see here today. So we're going to actually talk about a lot of different technologies, a number of different technologies that already play well together, but they're all based on Spring 5. We'll look at Spring Boot 2.0, right, which is due at the end of the year, ideally in time for Spring 1, knock on whatever that is. We'll look at Spring Security 5. We're going to look at Spring Data K? No. Mm-hmm. Ingalls? K. I think it's K. We'll look at Spring Data K. We'll look at a lot of different sort of technologies from the ecosystem already supporting Spring 5 as a baseline. And Spring 5, by the way, is a Java 8 baseline. So you'll see that it's, in some respects, very familiar territory, but it's also pretty interesting. It's a pretty new territory, right? It's all Java 8, it's Lambdas, it's functional, it's asynchronous, and so on. So hopefully you'll be able to sort of dive right in without any extra fanfare. So I think with that, we should actually build something.
Sure.
We need an application. We need something that we can work with. And so he and I thought long and hard, a good 5, maybe 6 minutes. And we thought about, what kind of sample application could we build? And I wanted to build a distributed chess game, and he said that was unrealistic and very complicated and pointless. And he was right. He was right. It was all those things. So we thought about other things, and we talked about movies, as we often do, because we're both movie fans, and we chanced upon the idea of having some sort of service. Again, hear me out here. We had the idea that we could build some sort of service that allowed us to work with movies. Now again, movies are often referred to as flicks, right? They're plural. Flicks. So we thought, couldn't we build something that allowed us to work with movies? And again, hear me out. Hear me out. Couldn't we build something that allowed us to work with movies over the net? We could call it Netflux. You see, we have in our project Reactor, a sort of operators that serve what we're trying to do here. And that project itself builds on top of the Reactive Streams initiative. In the Reactor project, we have 2 specializations of the publisher type. One is called a mono. A mono is a publisher that produces 0 or 1 value. And another one is called a flux. And a flux is a publisher that produces 0 to n values. So Netflux is, I think, what we're going to go with. So we're going to build a new service.
And then we can truly ask, got flux?
Yeah, exactly. So we're going to build a new service here. How do you clear the screen here? Oh, there we go. Sweet nectar. So yesterday, I made my poor friend Mark here use my Linux machine for a presentation.
It was really fun, too. As somebody who lives on a Mac, that was really, really exciting.
And I used to be, I used to know my way around a Mac, but the muscle memory's kind of gone. So now I'm on a Mac, having been exposed to Linux for the better part of the last year. So we're going to see what happens today. Just keep that in mind. If you see me sort of spasming on the keyboard, that's what's happening, right?
He watched me carefully all day so I couldn't remap keys. Just
right, yeah. And boy, did he try. Saw him sneaking away into the bathroom with a laptop. What are you doing? So awkward. Okay, so we're going to build a new service today.
We're going to follow me on.
Yeah. We're going to build a new service today. We're going to use the Spring Initializer. How many of you know the Spring Initializer? I just want to make sure we're all on the same planet. Okay, very good. So we are at the Spring Initializer. We're going to build a new service using Spring Boot 2.0 M3. This is the latest and greatest version of Spring Boot. I'm going to build a new service. I'm going to call this the, what do you say? What should we call it?
Marvin?
Maybe FlexFoot Service. Now,
oh, sure. Go with the obvious choice.
That one has the added benefit of being abbreviated as FFS, or for Flex sake, right? So we use that. And what we're going to do is we're going to build an application that uses Lombok, which is an annotation, compile-time annotation processor. That's very convenient. We're going to use the reactive web support here as well, of course. And then we have to choose a data access technology, some sort of data technology. So we have a lot of different options here. What you do not see here, first of all, what you do not see here is JPA. Right? JPA is a synchronous blocking API. It's a subset of Hibernate, which is also a synchronous blocking API, because it, in turn, builds on top of JDBC. So it's blocking and synchronous all the way down, right? There's no easy way to make that work. And there's no point in us trying to surface the JPA API as a reactive API, because we'd be creating a more convoluted API on top of something that is still, at the end of the day, imperformant. So you're not going to see that here. But Mark sent me some messages last year. He was at Oracle Java 1 last year. He was in the audience, and he sent me this stream of messages, and I couldn't believe what I was hearing. He said that they were talking about in the community keynote.
Yes.
Oracle had suggested, if only for a minute, how long were they on stage talking about it?
At least 10, 15 seconds.
Wow.
Yeah.
Wow. Okay, so this is a big deal. So they suggested, maybe it might have been gas, but there was a slide, so maybe it wasn't gas. I don't know. You can never tell. So there was some discussion of having reactive JVC support, not as an evolution of JDBC proper, but as like a splinter project or whatever?
Yes, I think it was kind of mentioned in passing. That would be the best way to put it.
Okay.
Yeah.
Well, anyway, that fills me with perhaps a foolish amount of optimism that within the next 10 years, there might, knowing Oracle and how dedicated they are to progress. No, I can't. Well, in theory, in the next decade, we could see reactive JDBC. But that is, I think, a fair ways off. At least it's not here right now. So I'm just keeping my fingers and eyes crossed. Who knows? But in the meantime, we need to talk about truly reactive, truly supported options. And so we have a number of options here, surfaced as Spring Boot auto configurations. And now, these auto configurations represent a subset of what's actually supported in Spring Data, right? You see here that we have reactive Redis, we have reactive Cassandra, and reactive MongoDB. And while all of these are fine choices, I think we should use reactive MongoDB because we have it running on this machine, right? That's part one, and it's fairly prolific and people know how to use it. And so, if you want to lose your data, and you want to lose it reactively, then use reactive MongoDB.
And it takes so few resources because it doesn't bother saving everything.
No, it's very, very fast.
Yes.
It's very fast.
Just like that.
Yeah.
You might even say it's web scale.
It is web scale. Yeah,
yes.
That's true. That's not just my, Oh.
Oh.
None of that here. All right.
Wait. Just so you know, I'm supposed to be the only heckler in the room. All right? So knock it off.
Oh, it's in his contract.
It is.
Okay.
It is. Some people aspire to it.
So we have our new service. We're going to build this here. And we're on the desktop. Hooray. Okay. See FlexFoot Service. Idea. That is not a thing. Of course not.
Oh.
Santa Maria. Okay. There we are.
You know, you can't just type open, right?
All right. So
I forgot to mention that. I don't know why.
There we are. So we have our service, our FlexFoot Service. Can you see that? Should I make it a little larger?
And big enough.
Is that big enough in the back? In the back, you okay? Yeah, he's okay. Oh. Anybody having any problems? I can change it. You are? Bigger, please. Bigger. Done.
We can turn this up.
We got this. We have the technology. Font. Okay. This is not confidence inspiring. Let's see. 1717. What the? Who doesn't?
I have all these settings that I've created specifically because they work really well in rooms, large rooms. And he's like overriding every one of them manually.
This is what I think of you and your well-laid plans.
Because I think he thought I needed more stuff to do tomorrow. I don't know.
Yes.
I don't know.
So where do we even keep your fonts here? Current font, Menlo 14. 16.
Yeah.
Wait.
Great idea. Great idea.
How's that? Can you see that? Is that any better?
Was the same guy you said that the same guy you said WebSphere? I just
That was
curious.
different. Oh. Okay, so we have a brand new application, and we're going to need to model our domain, right? So we're going to have movies. So I think we should build an entity to model movies. We'll call this a movie type. We'll use the Spring Data document annotation, and we'll give it a string ID here. And we're going to use the @ID annotation from Spring Data itself. And then we're going to create a title, not an idle, but a title. And we're going to say that we want this to be a non-null value. And the reason we're going to do that is because we're going to use Lombok, the annotation compile time processor, that will generate, for example, a required argument constructor and make short work of creating a constructor for us. And we'll use @data as well, and that'll generate getters and setters and so on. So
No args.
No args constructor as well? Oh,
Yes,
yeah.
please.
Very good. Thanks for that. So if you inspect the entity here, you see it says m.getID, get title, set title, etc. So all that comes for free at compile time, obviously. So we've got now an entity, and we need to be able to work with this to be able to persist entities of this type, to manage it, to be able to manage the data, and so on. So we're going to create a repository, and this should feel altogether very familiar if you've ever used Spring Data, and that is by design. We want this to be straightforward, and you should be able to see what you're working with and have a known sort of quantity of what's different. So we have the Reactive Mongo repository that manages entities of type movie, whose key or primary key is of type string. And if you look at the interface definition here, you can see that the methods are fairly well, fairly recognizable, but the return values and the input values are different. Our insert methods take iterables, of course, but they also take publishers. Right? They can produce a potentially unlimited amount of data, and they return specializations of publisher, mono, which, as I say, is a publisher that returns 0 or 1, or a flux, a publisher that returns 0 or many, right? Potentially unlimited amount of data. So we've got now a repository, and now we can save some records in the database so we have something with which to work with. So we're going to create a movie initializer, and this will implement application runner, which is a callback interface in... override methods. So we're going to use the application runner callback interface, and this is an ideal place to do any kind of initialization, which is what we're going to do here. We're going to actually create some sample records and then persist them to the database so that we have something with which to work. And this is where we want your help, right? We need to think of some movie names, right? So let's see. We're going to have a publisher with just different movie names, and the idea is we want to have movie names named for some of the types that we're going to use in this brave new reactive world, anything that comes to mind.
And this is truly the most important part of this evening, because if we don't get some really good titles here, the rest of it, it's just, yeah, it's sad.
No, these have to be related to reactive types and so on. So what's that one that our friend Phil Webb had? Was that our friend Phil Webb had a great one. What was that?
The silence of the lambdas.
Yes.
Yes.
Silence of the lambdas. There we are. Good stuff. What else do we have? What's that movie with the flux capacitor? Can anybody remember that movie? Back to the Future. Thank you. Anybody here a fan of anime? That is so awkward. Thank you. Aeon Flux. Very good. What about sci-fi? Anybody sci-fi horror thrillers? What was that called?
Enter the Mono Void.
There we are. Yes. Right.
We're reaching here a little bit, but that's okay. Yes.
The what?
Yes.
Yes. That had to happen.
Yes, it was bound to happen.
You ever see that amazing movie? It wasn't quite as popular as the first one, but it was popular. I mean, there were some people that watched it. The Fluxinator, right?
What about Meet the Fluxers?
Yes.
You see, once you get started, they just kind of roll off the tongue, right?
And they get better, I promise you. Every
Yes.
single one
No,
gets
no,
better
that's not true. You can't
and
promise
better.
that.
Okay, never mind. Here, have a promise. We were just in Spain. We gave this presentation, and in Spain, of course,
Yes.
mono means monkey.
Yes. Mono.
So we got some great options. We got some great suggestions there. 12 monos. Right. What else do we have?
What about the Cuarón picture? ¿Y tú, mono, también?
Yes. So the original
and
one
your
is
monkey also.
and your mom as well, and to you and your mother as well. Anything else?
Something's got to flux.
Yes. Some things got to flux, and that was another. There was another great Jack Nicholson pick called One Flux
yeah,
over the Cuckoo's Nest.
C-K. C-U-C-K.
Is it that? Okay.
Yep.
Spelling. What even? Okay.
Yeah, see, again, this would stop. I mean, this stops the whole demo if we mess something up like this. So.
Yeah, we will come back. If you
Yes.
think of one like halfway into it, that's okay. Just
Shout
yell
it
it out.
out.
We will stop what we're doing and go back. It is literally the most important thing we will do here tonight is making this part better. Okay,
Yes.
so we have names. Now what? We need to turn those names into movies. So we're going to flat map them, right? So for each name, we'll turn it into a new movie.
We should probably map that, actually.
Map it, okay. That's a good point. Whoa.
Okay, does anybody have a jar where we can start like a coin jar every time he hits the wrong keys? Because that was last night. I racked up at a penny a shot, what, like $5-6 worth of...
It was awkward.
Yeah.
I
Not my
know.
finest moments. Hours.
Minutes. Okay.
See, it just seemed like weeks.
Yeah. So there's our movie flux. So what I've done is I've mapped over every single one, created a movie, and then saved them into the database. And now what I want to do is I want to confirm that everything has happened as we expect. So I want to respond to I want to say at the end of that flux, after everything has been done, after everything has been emitted from that publisher, every value has been emitted from that publisher, I want to do something at the end of it. So normally you'd use the subscribe method. This is how you activate a pipeline here. I've got a reactive pipeline, but up until somebody subscribes, nothing happens, right? This is a definitional pipeline. Up until here, nothing is actually going to get executed. It's very similar to the Java 8 Streams API. There's a terminal method that you have to call in order to activate the processing. So here I've got a subscribe callback. The first variant of it takes a consumer of movie, and that's certainly useful, but that would give me every single emitted movie. So every time we see a saved record, I'd get a callback in my consumer. That's not what I want. I could use the second callback variant here, but that takes a consumer that gives me that accepts a consumer that responds to any throwables that were emitted, any exceptions that were thrown in the processing, and that's not what I want. What I want is to have something get run at the end of the processing, right? So I'll create a runnable here as the third parameter, the third overload, and all I'm going to do is I'm going to say mr.findAll.subscribe, and I'll just print out everything that I've seen that's come back. Now let's go ahead and try this. Let me see. Control. What do you think of that, huh?
Not bad.
Not bad.
I didn't get that one remapped.
Okay, well,
We're close.
we're close, but something's not quite right. We didn't create that many records, not even close, right? We have far more records here than we do here, and I think I know what's happened here. You know how a broken clock is true twice a day? Well, even MongoDB will, on occasion, save some of your data. And so what has happened is that in previous runs, some of this data has been persisted and survived.
Not the important stuff.
Not the important stuff.
I mean,
Definitely
the key
not
stuff
the
is
important
gone,
stuff.
but-
It's all the important data is gone.
Right,
Believe me,
right.
you are hosed. But some of it is still there. Maybe Mongo's still just getting around to it. Right?
Sure.
It will delete it eventually.
Yeah.
Right. So the point is, we need to delete the old data so that we don't have this additive list that gets longer and longer on every single run. So what I'm going to do is I'm going to go first. I'm going to go up to here. I'm going to say mr.delete all, and I could just block. I could just say delete all.block. But when I did this the first time, and Mark, you were there.
Yeah.
You saw that look of anguish. I showed this to my girlfriend, and she looked at me like she had just made a very terrible, terrible mistake. Why would I write this code? Why would I use this highly reactive, highly asynchronous API only to then clobber it with this blocking call? What's the point? So instead of blocking a call, what I want to do is have a dependent call. I want to say delete all, then do the results, do the processing that we see here. So let's string these together. And put that publisher, the publisher that gets created here, let's put that in the then many call. And then as a result of that, we'll have our final subscribe call, right? So that's a little bit better. There we go. So I'm writing fairly imperative code, but I get asynchronicity. I get the sort of benefits that we're looking for here, and I don't have to worry about arranging it. Now, keep in mind, behind the scenes, even though we're running this code, there is a scheduler. So there is no reason, for example, that this couldn't actually happen in 2 separate threads or in multiple threads or whatever. All of that is a detail of the sort of scheduler in play that's happening behind the scenes. You can override that, of course. There's different calls that you can make. For example, subscribe. Subscribe on scheduler, etc. That gives you that, and so on. So you can do all sorts of interesting things there. But for now, we're just taking advantage of the default configuration. We have that scheduler in place. We can write imperative-looking code, but we still get the benefits of that scheduler. It's reason. You can reason about what's going to happen, and it'll be correct. So this takes a lot of the pain out of writing, sort of asynchronous and concurrent code. All right, so we've got data written to the database. We've pruned the list as we expected to just these few records here, right? That's not so bad. What else, my friend? What else do we need to do?
Well, I mean, this whole thing is about creating a service, right? So we should probably maybe make a service.
Let's do that. Okay, let's build a service. So we want a movie service. And the movie service is just that. It's a regular old service. And the movie service will, I think we're going to have a few different use cases here. We're going to have we certainly want to be able to get a single movie by its ID.
Sure.
Probably want to get all of the movies.
Probably so, yeah.
And in today's world, I can imagine wanting to look at, I want to be able to socialize information about who's watching what movies. Wouldn't it be interesting if I could log into a system and see who all is watching the same movie as me, for example, or just see a stream of the events of other people watching, maybe from an operations perspective. I want that single pane of glass, that single stream of all the movies. So let's create another endpoint to stream the streams, right? To stream a log of all the streams. So we'll have a thing to capture that as well. So okay, we're going to use our repository. We're going to say private final movie repository, like this. Okay, and we're going to create an endpoint here. This endpoint will return a flux of movie. We're going to return all of the movies. Okay, there we are. This one's fairly straightforward. Okay, we're going to have a mono of movie just to get the one by ID. So string ID. Okay, and we'll say mr.find one ID. Sorry, find by ID. Thank you. And finally, we need one that returns a collection of events. So again, we don't actually have a type that we can use to describe that. So let's create a movie event type. And this is just going to be an at data Lombok annotated component here. And we'll have in this type a date, when, and we'll have the movie in question, of course, as well. So there we are. We need, say, all args constructor, no args constructor. There we are. And this endpoint will return a flux of movie events. So events for a given movie ID. Okay? Now this one's a little bit more interesting. We don't actually have, as far as I know, how's that call with the VC going? Do we have customers lined up?
Yeah.
Yeah, okay.
Sure. We'll go
Guess
with that.
not. So for now, we have no real users. So we need to fake it until we can make it. And this is a great chance for us to play with some of the low-level operators in the Reactor API. Here, we can create a publisher that produces new movie events, but we don't want to just return, a million a minute, a million a second, for example. We don't want to just go all out. That's not realistic. Let's just assume that somebody's leisurely logging into our system and watching a new movie every second, right? That's the fake it until you can make it principle. So we're going to create a publisher that produces a new movie event, but we want to gate it, right? So we want to gate it so that it only produces one value every second. And this is where that inbuilt scheduler comes in handy. So we're going to say flux.generate, and here we'll use a callback here that says sync.next new movie event. Okay? And what we're doing is we're going to pass in the new date and the movie in question. We'll look up. We'll figure out how to get this movie in a moment. But for now, we know that we're going to have looked up a movie, and it's going to be non-null. So here we are. Okay, so there's our first publisher, a publisher of movie events. Movie events, right? We need to gate that as well. So here we can say interval duration of seconds. We'll create a new publisher. We'll create a publisher that produces a new value every second. Interval publisher. And what we want to do is to compose those so we get one value from the left, one value from the right. And we only proceed taking another value from the left as long as we have a new value from the right. So they're gated. One is locked in lockstep with the other. So we're going to use the zip operator here, flux.zip, movie events, interval. And that'll give us back a publisher, which is a tuple. So we're going to say return tuple to flux dot flat map tuple to get T2, right? Is that the wrong one? T2?
Yes, T1.
And also this is a movie event?
Yep.
Is that right?
Yep.
No.
Yeah. Yes. You can just hear the money being generated, can't you?
T1. Yeah.
It's a good model.
What did we do wrong?
Seriously? No other movie buffs in here? Come on.
Map even? No, that's definitely flat.
It is map.
It is
no,
map.
It is map.
Wow. So maybe it was T1 and map, T2 and map. Come on, Heckler.
Hold on.
Return
Events,
tuple
interval,
to flux.
zipping movie events, interval. Yeah, it's map.
Oh, this is
T1.
This is why.
Oh, there it is.
This is where the type systems helped me.
Map. You can't flat map it yet.
Yeah. Okay. T2.
1.
Ha! There we are.
We're there. It sometimes
Okay.
takes a while.
So this is all of this, of course, assumes we have resolved the movie. So we need to actually resolve the movie. We'll say by ID, passing in the ID. That'll give us a movie mono. And what we want to do is we want to take that mono and turn it into a publisher. We have a publisher that produces one value. We want to turn it into a publisher that produces many values. So we'll say flat map many. And then that movie will be a parameter that we can pass in there. So we say return, and all of this code just goes in there. Okay, there we are. There's our simple service, our little endpoint that produces a potentially unlimited amount of data. All right, we've got a service. Does that look okay?
It
How do we
looks
know?
good, but boy, wouldn't it be cool if we could test that?
My code is fine. It's perfect.
Yeah, but let's just say, for instance, it might not be.
Right.
You know, because again, I did remap some keys. So it would be really cool if we could test this. Now, last night, somebody shouted out a great idea, a great way to test code. You push it to production, right?
Right.
Okay, well, okay, maybe not. But that is one option, certainly, that a lot of people seem to employ with mixed results. What it would be really cool is if there was, oh man, now I'm doing it. Oh my gosh.
I remapped it.
I feel like oh, well, anyway.
It's going to be okay.
So it's going to be okay. But I do need some time on your Linux laptop again, I guess. So. All right, so wouldn't it be cool if we could test this? So the good news is we can. So let's see. Let's open this. Has anybody ever seen one of these?
Yeah.
I know, isn't this neat? I'm going to clue you in on a really cool secret. We can test stuff this way. So I'm going to do a get events, and we're going to take 10. Nice descriptive name, right? I will say that most of the time, when we show you stuff, we try to use at least a semblance of best practices because we don't want to promulgate bad habits. However, once in a while, once in a while we do take a shortcut because we don't have unlimited time. So when we do that, we do try to say, hey, this is a shortcut. Don't repeat this so you don't go in tomorrow and say, hey, Heckler said this is okay, or Josh said this is the way to do it. I'm going to take a couple shortcuts here. For starters, I'm just going to do some very nice field injection here. So let's see, what do you call this? Movie repository? No, movie
service.
Service, there we go. Okay, so we'll call this service. And then let's do some testing. Is anybody here a fan of Doctor Who? I guess I should have opened with that question. Okay, a couple. That's good. Yeah. The rest of you, I mean, by the time we get out here tonight at what, 11 o'clock?
11, about right, yeah. 11,
you got some time to watch a few episodes tonight. New Who, starting with Christopher Eccleston, highly recommended. But the reason I love Doctor Who is he travels through time and space, or she travels through time and space after the Christmas episode. So, hey, hands off my keyboard. He's so naughty. Anyway, so we're going to do a little bit of time traveling. This is very important when you have asynchronous code. When you issue a request and expect a response, and you can test for that, that's fine. Imperative, it's fine. But when you have a flux that may produce a value sporadically, and it may produce 3 values in 3 seconds and wait another 3 minutes for another value and then another week for another value, that can be a real drag to test, right? So we need some way to kind of step through time. So that's what we're going to do. Let's see, where was I now that my cursor's been moved? So anyway, let's start first with just grabbing any old movie. So I'm going to do this, service dot, let's see, all, right? And then we will block first. Now this, again, is not a best practice, but this is a test case and this is a demo, so this is why I'm going to do this. So we have a random movie. So now what we want to do is employ step verifier. Step verifier, right? Step verifier. Wow, I didn't realize how badly I was messed up. I was laughing at you, but this is really kind of sad. Now this is the cool part with virtual time. This allows you to compress time and speed things up so you can actually get through your tests in very rapid order. So we're going to, let's see, start with this, and let's see, we'll start with getting our service dot, let's see, events based on movie.getID, right?
Looks good.
Sure, let's do that, and then we'll take 10 of those, and then we will collect those. Collectors.toList, so we get a nice list out of that. And then we'll await, and let's give it some time.
Some reasonable amount of time.
Some reasonable amount of time so we can get 10 values out of our flux. So a duration of
a week.
Hours, 1,000 hours, that ought to do it.
That'll be enough, yeah.
Sure, that doesn't seem excessive at all. And then we will consume that. Now we have a list, right? So we're going to, in this case, I'm going to assert list dot assert true. Thank you very much. List dot size equals 10 because we should expect 10 values, right, in our collection. So in our list, and then we'll verify complete, and hopefully that'll work. If we've done everything right, if things are working right, if Josh's code is working correctly,
And there's no doubt about that.
so are we ready to run this?
Not much doubt anyway.
Not much doubt.
I'm not that worried. I mean, it's probably fine.
Probably fine. What happened? It's still running. Uh-oh. You want to go back and look at your code again?
My code.
Well, it can't be mine.
Okay, let's go back to my code.
Let's go back to his code. Okay, let's start there, right? Because it's the test is doing what it's supposed to do, right? We hope. So let's see what we have here.
Let's try it the other way. What's another way to rewrite that?
Okay, sure. Let me just quickly comment this out. Let me take a run at it. Completely unscripted, by the way.
Yeah.
It's kind of funny because we both kind of give this talk and we both kind of come together and we blend and mesh and tag team on styles. So let me take a run at this. So let's see, what are we going to do? Return by ID, right? ID, right?
Got the movie.
Dot flatmap mini.
Yes.
What do you call this? MR, right?
Mm-hmm.
MR dot. Wait. I'm sorry. Yeah, I need to generate these, right? Right.
We've got the ID. Yeah, we're going to generate with a delay.
Right. Okay, so let me start this. Flux dot movie event generate. Okay, we got a sync dot next, new movie event, and you got your new date, right? Movie, only we don't have a movie yet. So, yep, we'll just do this. Let's see. Dot delay elements, duration of seconds 1, right?
Looks good.
That looks good. So return.
By ID, flat map mini.
Yes, that's exactly right. Okay, so by ID, and this is our ID, right? Dot flat map mini. Boom. Actually, I need to go
We need
here.
the parameter is the flat map mini
Right.
callback.
Movie.
Okay.
Yep. Movie. Right.
Nice.
Does that look right? Everything.
Okay.
Something's.
Only one way to find out.
Yes. Okay.
Oh, it's something red still?
Yeah. Well. Nope. That's fine.
Yeah, that's fine. Just
That
take
is
it.
fine. Okay. So. Control Shift R. Did I get that?
Yeah, so you're running the code, not the app.
Okay.
The
Yes,
test.
that's exactly right. Okay. So let's switch over to here, and. Oh, I think it is my test case. Oh, crap!
Can you try killing the application? Because I think this is trying to start up the server and then it's not actually receiving an error event because I don't think you're handling it. Try killing the application and then running the test maybe.
That's a good point.
Okay.
Kill everything.
Yeah, it is, actually.
Yeah, that's the app. Kill the app.
Oh, yeah. Yeah, sorry. Here we go.
Run.
Kill. Run the tests. Let's just make sure we got this right. Boom.
No?
Mm-mm.
Wait, is that application still running? It's very unsatisfying.
Nope, it's not.
Goodbye.
Okay, this is a first. Normally, we never have bugs in our code. So
We just do the test for you.
right.
Let's see, window, command 4, that's this one, command 5.
So we've written it 2 different ways, and there's a problem both ways.
Divide that. Okay, step verifier. What could be different, my friend or friends? Well, there's no reason not to cheat in such a situation. So GitHub, Josh Long. This is why it's online, because nobody remembers everything. Flux service
Test. Oh.
test. No.
Nope.
Lies.
But the tests, I think, were written when we were using Movie. I don't know. Let's find out. It's the top one. Yeah.
What?
It is lies. It is lies. The cake is a lie.
So wait a minute. What did we do yesterday that was different?
We just used Movie instead of the ID. No,
Well-
it's only up to. Yeah.
It's supposed to be, yeah. Right, so movie ID. Don't understand. What could,
Here.
Yeah,
Oh,
well,
it's movie events,
it's
actually.
movie events. It's unlimited
So-
stream.
Let me do something different here, just for giggles, okay?
Okay.
I'm going to create a Flux movie event, right? Events by movie, and we're going to pass the movie as a parameter, right? Return. Let's see. Okay, so Flux dot movie event generate sync. Come on, sync dot next. New movie event, right? New date. Movie. Okay. Dot delay elements duration of seconds 1. Boom, boom. All right, so, yeah. Come on. All right, so let's test that one. Let's see what we come up with. And then we change this to just movie.
So it's events by movie.
Yep.
Yeah, change the method call. Service.events.
Service.events. Oh, yes, thank you very much. By movie. There we go. Okay, so now let's see if we're cooking with gas. Oh, that looks so nice, doesn't it? Okay, so obviously we have an issue we need to identify in our code,
Right.
but let's go ahead and charge on and
Moving on.
We'll adapt. So we assume this is working right, finally. So let's find out. Let's just make sure this isn't a head fake. Let's go ahead and rerun this. Making sure that the list is not equal to 10, the length of the list, and of course it isn't, because this is for real. Never once do our fingers leave our hands. So let's go ahead and rerun this. It's all good? Yes, okay, so we're good. So we know that the service we created actually works. We know that that our test case, our unit test, has proven to us that it is working. So now, let's push it to prod, right? Okay, so we have the service in place that we need, that we have to underpin all of this. Now, let's create an API.
Please.
Why don't we? Okay, so let me switch back over to this. Boom. Okay. So, there are many ways you can go about this. If you're coming from a Spring MVC world, this will look very familiar to you. One thing that I think, and of course I'm very biased, I admittedly am biased, but one thing I think that we're doing very right at Pivotal is that we don't tell you that, congratulations, you poured 10 or 20 years into developing a lot of very critical systems. Throw all that crap away. Do it our way. Do it differently. You can approach it in a style that is very similar to your existing systems. It will be a very gentle and gradual on-ramp for you. You can also take a different approach if you're coming from a different perspective, and that's cool. We're going to twice the effort and investing a lot of time and effort into creating a lot of good options for you, and I think that's excellent. I think that's a great way to increase adoption and to do so in a way that you get the full power without having to kind of abandon the hard-won knowledge that you've built up over the last few years. So let's start with that.
Okay.
Let's start with a way that is probably very familiar to you. We're going to create a REST controller, right? And I'm going to do a request mapping on /movies. So we're going to define our movie anchor point for our endpoints, right? And we'll call this class movie controller, right? Naming things is hard. Private final movie service. Yes, okay, movie service. And let's get started. So I'm going to define an endpoint here where we can get all of our movies, right? So public, let's see, flux of type movie, right? And we'll just call this all. And we'll return movie service dot all. Yep, pretty simple, pretty straightforward, pass through. And again, looks very familiar with what you're probably used to seeing. We're going to create another mapping for movies for a particular ID. So we can identify, locate, retrieve a mono of type movie. So again, we're going to do this retrieval reactively by ID. So we'll call this, again, whoops, let's see, public, getting ahead of myself. I'm getting so excited. By ID, right? And we'll, of course, leverage a path variable to pass in our ID. And return movie service dot by ID. Again, by ID. Very simple, very straightforward. So now let's take it up a notch, right? Let's for a particular movie, let's retrieve the events. Again, as Josh said, we have a stream of events. So while we're watching a particular movie, we can see how many other people have the same excellent taste that we have and are going to start watching the same movie that we are. So when Rob starts streaming the movie that I'm watching, I can say, gosh, this was an enlightened choice. Rob is watching this movie. I feel validated. So, of course, as with all things in 2017, to do something is okay. But to do something and talk about it on social media, that's awesome. So we're not quite there. This is our minimum viable product. But we're going to start seeing that stream of people starting to hit that movie and watch that same movie, that same flick that we are over the net. So, again, back to Netflix. We really should like trademark that title, don't you think?
Netflix, exactly.
Yes, I think we should before somebody else steals it. So we're going to retrieve a flux of type movie event, right? And we'll call it. What do you like to call it?
Events.
Oh.
Or
See,
the
normally
stream.
he has such great names. I feel so let down.
Well, I was thinking about this because we are streaming, in essence, people's watching the movies.
Right.
When they're
So
streaming videos, we're streaming it. In essence, we're
stream the people's
No.
No?
I think we should call it crossing the stream.
Okay.
We're doing it.
Cross the streams. Okay. Against our better judgment, we're going to do that. This is like a Twinkie the size of Manhattan, right? Okay, so we're going to leverage, again, a path variable for the ID in question, right? So what are we going to do here? Return, let's see, what are we going to do? So return MovieService dot events by movie, right? Only before we can do that, we have to do one thing. We have to do a by ID, right? By ID. Let's see, dot, let's get rid of that, flat map mini, because we're going to take that, that mono of type movie, and we're going to flat map that thing, and then we're going to, let's see, service, movie service, events by movie, yeah? That work?
Nice.
Should work. Should work.
LGTM.
But again, there's only one way to find out, and that's to run it in prod. So let's do that. Oh, it's going to run my test again. Hold on a second.
Which is fine because it's fast.
It is. It is lightning fast. We don't have to wait 1,000 hours or anything, so that's good. Oh, that's much better. Okay, so now we're up and running. So let's check this out. Oh, that's good. That's good. Clear. So let's try this. HTTP. Does anyone else use HTTP? Oh, it's so pretty, isn't it? It's
So
too
nice.
bad that's not on Linux.
It is on Linux.
Oh, it is?
And we
Why
use
don't you use it?
Because most people don't. It's not a tool everybody uses. I use curl for
What's-
stage.
You're an
Postman.
advocate, though, right?
Yeah, but I'm not advocating for other people's tools. I don't care.
Okay, well, anyway, I like it, so I'm going to use it.
Use it.
So I'm going to, and you notice a nice shorthand, right? I don't have to type in the HTTP localhost. It just knows. So we're going to retrieve our movies, and we have some really great movies here. So I'm going to take one of those, the something's got a flux, and I'm going to add that as our ID, and we get that. So now, let's do something else, but I can tell you right now that it's probably not going to be the outcome that we're expecting. So I'm going to try to stream the events, and nothing happens.
Awkward.
Awkward. Why is that?
I can take a guess.
Take a guess.
Well, I'll bet the client isn't prepared for the all-out assault that is our unending stream of movies.
Why would that be, though?
Content types.
It is, and that's the thing, because we're not providing a package that then our client can turn around and extract the contents from. We're providing an open-ended stream of values. We need to somehow signal that. Oh, see, it just timed out. It's sad. So we need to somehow make this a little more useful, a little more helpful. So
Our client was sitting there waiting for the end of the JSON document, the application JSON document, and that never came, right?
Here's what we need to do. We need to provide some kind of a hint so that we can generate a stream of server sent events. Now, Project Reactor does support, and Reactive Streams do support things like WebSockets. But WebSockets is bidirectional. Right now, all we care about is a pushed stream. So we're going to leverage server sent events. And this is enough to go ahead and get us started with this. So let me go ahead and rerun this. And we'll see what we get now that I've got everything in my code that I should need, at least in theory. So we go back to here. We pull in our movies. Yep, everything looks good. We'll do one flux over the cuckoo's nest this time. And finally, let's check out our events. But the other thing that I do need to do is just give our client a hint that this is a stream of values. So now we see it's working. So we have working code. This is so great. However, right now, and as I mentioned, there are multiple ways you can go about this. There are multiple ways you can define your endpoints. And right now we've done so in a very imperative feeling way.
This is the Spring MVC style. Right?
Yes, and that's great because that gives you an easy, approachable way of doing things if you're very well acquainted with that approach. However, if you're coming at it from the other side.
Well, So one thing to keep in mind is that this is a Spring MVC style, but this is not Spring MVC.
Correct.
This is actually a brand new runtime called Spring Webflux. It's a separate module inside of Spring 5 that sits adjacent to, not in replacement of, Spring MVC. So while it may look like Spring MVC, the same mechanism is not in place underneath the hood, and you'll find that some of the types that you're used to aren't necessarily there. Behind the scenes, this is a brand new, net new reactive runtime. By default, it's running on NetE,
Yes.
right? But
However, However, you can run on any Servlet 3.1 platform, so in a degraded fashion.
yes, and that's a very, very useful thing, like you were saying before, where you can run this stuff on sort of traditional servlet environments, which is kind of a cool thing. Not that you should. You could, but you shouldn't, right? Sorry? Yes, but you shouldn't. You could, in theory, run this on. You could run this beautiful, fast, reactive API on top of WebSphere, but I would not recommend it. It's a bit like having a Ferrari and then putting that on top of an elephant. It would defeat both parties. Sorry? No, you don't. Don't lie to me, Frank. Don't lie to me.
I keep trying to tell him just to answer no, you can't do it.
No.
But he's too honest, so.
So to consume this API, you need a special client?
Well, let's not get ahead.
Yeah. I mean, this is a great question, so hold that question.
Yeah. There's a reactive response to that coming up.
And actually, I should ask, I mean, doesn't everybody stream their movies via command line? I don't know. Anyway.
Yeah,
Yes, that's true.
that's all I
yes.
got,
It's
really.
really hard to watch, though, because, this byte stream, it's,
I pipe it to the FFmpeg filter for the ASCII, the ASCII artwork.
it's so cool.
You actually see the movie. It's like a Matrix.
Right.
Right. That's right. Yeah, it's a unique experience, a unique viewing experience. Okay, so let's actually I'm going to take a quick drink. Let's approach this from the other side. Let's say you're coming from a Scala perspective, or Scalatra, or Ruby,
Or
for
Sinatra,
instance.
yeah.
Or Sinatra, yeah. Maybe what?
Spark Java as well.
Okay.
Yeah.
Any more bidders? Oh, anyway, so let's say you want to approach this a little more functionally. So let's do that. I'm going to define a component, and just for convenience, and I'm going to call this class movie handler. So I can define my handler methods. I'm going
Show
to.
them the reactive endpoints first, and then show them the extraction to handle.
Well, here you start us out.
Okay. Well, what I was going to say was.
Oh wait, we forgot. Hold on. Tag in.
Oh yeah.
Okay, now, we always skip that part. And
Always.
then it just, I mean,
So-
you saw what happened earlier when we skipped the tag, so.
We have this mechanism that allows you to define functional reactive endpoints, right? So it's just a regular configuration class, configuration. And we define a bean of type router function. Routes. Oh my. You changed the keys, didn't you? So
I'll never tell.
all we're going to do is we're going to say router functions
Functions, yeah.
dot route request predicates dot get movies, and then provide a new handler function. Now this handler function is a callback, right? And that callback, that's where you can actually write code like this. You can actually provide a programmatic predicate to describe the predicate that matches the request, and then the handler is right next to it. That's certainly one option, but it gets a little noisy if you have a bunch of code right here. So while you could clean this up a little bit, it's much nicer if you extract it out into a separate component, which is what he was about to do.
Yes.
Yes.
Okay, all right. So I'm going to just put a pin in that and come back to that. Let's see, did you delete my code?
No, definitely not. It's there. I left it with love and
You
no, keep going. Scroll down.
no, it wasn't that far down.
Stop. What?
What'd you say? Oh, man.
Started from the bottom, now we're still there.
Yes, there is video evidence. Okay, well, anyway. Curses, foil again. Okay, so I'm going to start over because I've gotten so far into this. This is probably going to take hours to catch back up. Okay, so we're going to call this class movie handler, private final movie service. Yes, service. Yep, service. Boom, boom, boom. Okay. So let's define some endpoints, shall we? So we're going to return a mono, and now I can't type, of server response. Thank you very much. So we're going to define some methods which take a server request and return a server response, but a reactive, a mono of type server response, right?
So we're basically just implementing that same interface type. It's a functional interface.
So let's see, we'll call this, let's see, all, right?
Yep.
So return.
Needs a server request.
Oh, yeah. So server response, right? Oh, yes, I forgot this. Server, that's what you were telling me. Server request. Boom, request. Thank you. Server response dot okay, because everything's okay, right? And we'll return a body. And of course, we will access our service. And this is for all, right? So all, yes. And then this is of type movie class, right? So that should be sufficient. This is our endpoint that we're defining.
So how would you use that in place of what we had before?
Well, what we would do, I guess you're wanting me to jump around. This is a little unscripted, so bear with us here. So we're going to return a route, right? Let's see, boom, 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 boom. And actually, we need to inject our movie handler, right? And that lets us movie handler dot all, right? So that gets our route. Let's put a pin in that for now. Again.
Method reference.
Can do. Yep. All. Yep. Okay. So we'll come back to that. So let's define a couple more methods. We'll return again a mono of type server response, and we'll query by ID, right? Server request, return, service. Got ahead of myself. Oh yes, of course. Gosh darn, I always skip that. Server response. That's why he's here, to keep me on the straight and narrow here. Dot body, boom, boom, service dot by ID, right? And we're going to access our request path variable for the the path variable ID, right? Yep. And this returns also a movie, right? Close, boom, boom. Okay, so that should be good. Let's define one more, shall we? Public mono server response, and this will return our events, right? Server request, boom, return server response dot okay dot, and we need to actually insert a content type this time, because we're dealing with events here. This, again, is our server sent events. This isn't overly onerous. We're just going to specify a media type, assuming typing is not overly onerous, again, of text event stream. And then we will define our body. And once again, we do a service dot, let's see, what do we have here? Events by a movie? No, we've got events by...
you just have the events one, that should work.
Yeah, actually, since the other one we were having some issues with, let's go ahead and improvise a bit by ID, right? And at this point, we take our request dot path variable for ID, right? And then we take that, the by ID, and we flat map that. What could go wrong, right? To service events by maybe?
Yep.
Should work. But now we need to define that this is a movie event, not mouse event. I've done that before and wondered things went off the track. So, okay, so now we've defined our methods that will return the proper server response, or a mono-type server response for each different server request that we might make of it. So now let's define the rest of our routes, shall we? Okay, so we have our initial route. So let's do an AND route. Let's add another one here. So we're going to create another request. Predicates, I can't type. .get, okay, so we're going after movies /ID. So we're going to be able to pick up a particular movie handler dot by ID, right?
Or just method reference.
Method reference, why not? Go for it, all right. And then finally, we will access our last route, or provide our last route, predicates.get /movies /ID /events, yes? Yes, okay. I was trying to remember which, yeah, this should work. Famous last words, right? What could go wrong? Movie handler, events. Okay, so that looks right. Am I missing anything?
Command-Alt-L.
Command-Alt-L. It's so pretty. Okay, so let's do this. Let's see what we have. Let's see if we really did get it all or if we somehow missed something. So it's a little different approach, right? But the outcome should still be the same. So let's make sure that we didn't break anything in the process. So I'm going to access our movies endpoint. And yes, that seems still pretty happy. So let's go up here and grab 12 monos, or 12 monos. And let's access that. That all works nicely, like we ever had any doubt, right? And let's go back to our events, and let's stream those and see what we get. Oh, it's so good when things work. Yes, okay. So, what's next? Well, like we've done a lot,
We've done a lot. We have a super efficient, highly scalable, highly concurrent, highly reactive toy.
Yeah.
Yeah, it's a toy.
But it is a pretty toy.
It is a very nice toy, but it's just a toy, right? This is not, by any stretch, a production-worthy application.
Feels like it might be a little insecure.
It's
toy,
a little
right?
insecure, right?
Yeah.
Not just the kind of insecurity I have. It's like, it's not actually secure. It's a different kind of insecure. So we need to lock this application down. And this is really where, again, Spring has a really, we're in a useful position, very interesting position, because we have access to Spring Security. And Spring Security, of course, you may well know, I don't know if any of you have heard about Spring Security here in Kansas City. But Spring Security is kind of a big deal. It's been around for more than a decade. It's the #3 most prolific Spring project out there. It's being used by everybody and then some who's building applications in the Java ecosystem, even people who aren't using Spring. And that's a hypothetical, by the way. I acknowledge that in the same way that for the longest time, scientists talked about the possibility of the Higgs boson particle. It's possible that there are people not using Spring, but we just haven't been able to prove it yet, right? But anyway, if there are, it's in theory possible to use Spring Security even in a world where you don't use Spring, which is to say it's been very, very, very successful. And that has meant that over the last decade, there's been a lot of integrations, a lot of sort of really great integrations for every different type of identity provider that you can imagine wanting to use. There is an integration for that in the Spring Security world. So it's natural that we'd want to use Spring Security to lock down this application. And now, in the Spring Security world, you have this idea of an authentication manager. It, in turn, handles the question, or it responds to the question, who's making the request? And it actually delegates in turn to a chain of authentication providers. If you're trying to manage the authentication in terms of somebody who's making a request with a username and password, then you're going to be using something called a DAO authentication provider. That's the sort of traditional, sort of non-reactive Spring Security hierarchy. There's a specific thing called the DAO authentication provider. And in the reactive world, things are basically the same. There's a reactive authentication manager, and then ultimately there's something that handles requests for usernames and passwords. There's an interface in the non-reactive world called a user details service. That's the interface that you're going to deal with if you've ever tied Spring Security to your backend system that has usernames and passwords. In the sort of reactive world, we call that a user details repository. And so to use Spring Security, well, first of all, you need to bring in the Spring Security bits Haha. So you need to bring the Spring security bits. And there are, is this true, Rob? Is there a Spring Boot starter yet?
No.
Sadness. So you need to bring in, sorry? Yeah. It's a thing that'll happen eventually, asynchronously. Just subscribe to the Git commits. So you need to bring in Spring Security WebFlex, the module. And now we don't have to manage the version, thankfully. That's already managed for us. We've already got the 5.0 versions of Spring Security. Oh no, we've got the 5.0 versions of Spring Security, but we need to bring in the individual modules here. So core, config, and WebFlex. There we are. Okay. So once that's on the class path, it's fairly trivial to get the rest of it working. You say, security, configuration, add configuration, and the simplest thing that we can possibly do is just lock down everything. Let's just create the simplest kind of lockdown. We'll just say everything is inaccessible unless it's authenticated. And in order to be authenticated, it has to be a valid user. So we'll provide a definition of type user details repository. Okay, and the user details repository will return, contain a collection of users. And so let's just create a hard-coded list of users here. So user details, user, string, username. Okay, and we'll say user with username, authorities, and then we'll say user, password, because of course it's password, and then build, right? So that'll be a user, and we'll have another method here, just a convenience method for an admin, which has basically the same exact structure with the extra authority of being an admin, okay? So we'll create a bunch of users here. We're going to create a hard-coded list of users here. We'll say user JLong, user FM, there we go. We'll do admin rwinch and admin mkheck. So we're creating just a sort of static fixed list of users here. And we need to actually activate WebFlex security as well, so we'll do that. And that is enough to give us a very usable but basic sort of secured reactive web application. Or not. Or it'll just blow up in the most insidious, insane ways.
Reactive security on there because you renamed it to config.
Oh, in the POM?
Yeah, in the POM.
Awkward. Nope.
Command Shift O.
No, you. Okay, wait. Spring Boot. Oh, son of a gun. What did I do? Here's config. Here's core.
So you just need to add WebFlex again.
Did I get rid of it?
You had it, but you renamed it to
Snatched the defeat out of the jaws of victory.
It's the darn starter in this thing.
Yeah. Something out of here. Okay. Oh, it would have been so sweet if that worked. Sweetest
will.
thing
I'm
ever.
scared if it worked without
Yeah. Just take, if a miracle happens within 10 feet, take credit. All right. So there we go. There's our application. Okay, curl, HTTP. Sorry, what?
You could do it, man.
So it's going to fail, right? Minus V says it's 401 unauthorized, right? So we now make a request. We minus U and JLong password. And it still failed. Why did that fail? Look, oh, there we are. So there's our request. I made a curl request specifying an HTTP basic username and password, JLong password, and that went through. But we have no sort of notion of my authority, right? We've answered the basic question of authentication. Is somebody authenticated when they're making the request? We could be a little more specific in who, once they're authenticated, we allow to access a particular endpoint. So let's, just take this up one little extra level. We'll configure the endpoint security, the exchange security. So we'll create a web security filter chain. Security filter chain. I'm going to inject the HTTP security bit here, the config object, And we'll say HTTP security dot authorize exchange. And we're going to say that any exchange has to be authenticated, and we'll provide a specific bit of insight or a specific bit of guidance as to what then, once they're authenticated, what has to be true for them to be allowed through, and then we'll build. So let's see. Wrong one. It is a security web filter chain, and it's supposed to be a goodie. Okay. So this callback interface says, okay, when an authentication request comes in, use that as an opportunity to make the decision about whether that request should be allowed to go through. And so we can look at the authorization context, which is the sort of object that contains the information about the request, the resource, the endpoint, etc. And we can look at the authentication principle, the information about who has been authenticated, and use both of those to make the decision about what to do here. Now, we can do all sorts of interesting things here. What do you think we should do there, Mr. Winch? I could just re-implement your has authority thing.
Makes it look like you have to do all that for has authority.
Yeah, that's true. We don't have to do that then. Okay, so we could just say.
Username if you want.
There we go. Yes. Check the username for what?
See if the username is JLong.
So definitely don't let that guy in. So okay, authentication dot get.
I was going to do it the opposite.
Yeah. Auth dot get principal. Is that right? Yeah.
Mm-hmm.
And that is a user detail. Is that right?
You just need the principal. If you do dot get name instead of your principal, you have username.
Very good. Thank you. Yes. Get name. Yes. Okay. Equals JLong Santa Maria.
If he keeps doing this, I'm going to get a latte by the end of the night. This is good.
So we have to now turn that up into a. We have to map that into an authorization decision. New. Is that right? Map.
I give him a hard time, but it still looks a lot, like 10 times better than what I did last night on his Linux box. So.
What am I missing here? Let's see. Flat map. Flat map. And the parameter AD. Yes. Oh, Santa Maria. Okay, here we go. So excited about this.
Which way did it go?
Where did it go, George? Where did it go? Faster.
There it is. All right. Okay, good.
Okay. What was it again?
Flexing tiger hidden lambda.
Tiger. Hidden lambda. Yes.
Okay.
Oh, thank God.
Yeah.
Got there in time. Okay, so back to this. We have an authentication. We say, okay, oh, yes, right, okay. We say, if the authentication is not JLong, then we need to map that. No, that's actually right. What do we do here? What am I missing? Flat map this decision into a authentication new authorization decision. Why wouldn't that work? What am I missing here, Mr. Winch?
I always get mixed up between the flat map and the map. What's the dot on success after that?
Sorry.
I didn't say I would think it would be
There we
map,
are.
but I'm not. Okay.
There we go. That was hard. Okay, so there we go. Got that. Semicolon. And clean this up a little bit. There we go. Okay, so this is my custom authentication configuration and authorization configuration. So what I'm saying is, let anybody besides JLong go through, right? Fair enough.
Seems reasonable.
Yeah. So JLong, denied. Right? Now, our winch, there we are. See that on the bottom? Where's the data in the bottom? So again, we're able to use security here to lock down the application and do so fairly succinctly, right? We create this trivial toy map user details repository to get things up and running, and then we configure things, taking it a step further, overriding the default behavior using the sort of HTTP security configuration object. All right, not bad.
Not bad.
Not bad.
But we did have an outstanding question.
Right, which is what?
Something about a client, right?
Just use curl, that's fine. Okay, good night.
Yeah, okay. Thanks for coming.
No.
Or better yet, HTTP, but
Right.
HTTP, yeah. Say that 3 times fast. Anyway, so for those of you who somehow, the people who are never satisfied and they don't want to watch their movies via curl or HTTP, we're going to show you kind of the way you would possibly implement that. In the imperative world, in Spring MVC, you would probably use something like a REST template, right? But that's really not made for asynchronous communication. So we're going to be using a reactive web client. We're going to develop a reactive web client application just to give you a taste of that. So let's go back here and let's clean this up a little bit. We don't need Mongo because we're not going to be saving any data. Not that we
Or losing it in this case, yeah.
Or losing it. Not that we ever did before anyway. So let's go ahead and create a client. Let's see, boom. And save that. Yep. And let's open that. And let's open that. And once it comes up, the first thing I'm going to do right now, just as a shortcut, because I know that Netty is going to be firing up as well when we start this application. Obviously, we don't need that, but in this case, I'm going to go ahead and just reassign a different port for expediency purposes. Now let's go to our main application, and let's do some things. Whoops, not that. Okay, so the first thing I'm going to do is recreate our domain a bit. So I'm going to, once again, and I'm going to use Lombok because I'm a lazy developer. I don't believe in undifferentiated heavy lifting. So if I can avoid having to write a bunch of tedious boilerplate, that's what I'm going to do. So let's see, no args constructor, all args constructor for a class called movie, right? Private string ID and title. I think that should get us what we need. And then we also will want a movie event, class movie event, private date, right? Boom, boom. Private movie. Yep, okay, so now we have our domain established. Let's go ahead and do a couple things here really quickly. Let's create a bean, a web client bean. And let's see, return web client create. And we're going to specify our base URL. You don't have to do this. I just find this really helpful so we don't have to muck about with the long URLs later on. So let's start here. Let's see, localhost, where do we put this? 8080/movies, right?
Very good. Yeah.
Very good. Okay. Now, since we've secured our back end, we need to do a couple things to make sure that we can get through that, legitimately get through that security. So next we're going to, oops, not that, mutate. And finally, filter. Let's filter that. And we will use exchange filter function, right?
Yeah.
And
Perl.
What's that?
Exchange filter functions.
Function. Oh, God, yeah. Okay, thank you very much. And we're going to provide basic authentication.
So literally anybody besides JLong.
Yes. So JLong, right?
Nope.
Well, we need to start there.
Oh, to prove it won't work?
To prove it won't work. Always prove the negative first, right? And we're going to provide a password. Oh, boy.
Command
help, help. Password, right? Right, so that should be it.
Command 1.
What did I miss? Command 1. Oh, you just want me to close this out. Yeah, yes. Never mind. Okay, so this is not closed. Oh, build. Thank you very much. I always want to leave that out. Just should happen, right? I'm thinking it. It should happen. Okay, so the next thing I'm going to do is create a command line runner. We'll call this demo, cleverly enough, and we're going to inject our web client. So return strings, and let's get started on this. This is the fun part. So let's create our client, and we'll do a client.get, specify the URI. Since we've already specified our base URI for all movies, that's where we're going to start. We're going to retrieve all movies, reactively, of course, or we would if it wasn't Josh doing it, and Josh locked himself out. So, we'll start there.
We don't need the URI call in this case.
Just completely omit it, huh?
Yeah, remember we found that yesterday.
Well, you have to have there. You just, okay. All right, we'll do this. Okay, so let's do a body to flux since we're going to be returning objects of type movie, right? And then we're going to filter this because right now we have a list of all movies coming back. What we want is a movie that we can go ahead and retrieve based on that particular movie, the events associated with that movie, all of the viewers that are coming through. So we're going to filter this movie dot get title dot equals ignore case. Which one you want to use?
Silence of the lambdas.
Silence of the lambdas. Okay, so that looks pretty good, right?
Yeah.
Okay, so let's flat map that then, and let's take our movie, right? And let's again establish our client dot get dot URI, and we're going to now extend that a little bit for our ID that we're going to be providing and retrieve our events. And we'll take our movie and get ID. Yep, that looks good. So now let's retrieve, and we'll do a body to flux. And in this time, we're actually retrieving movie events, right? So let's see, what else am I missing? I guess it's just now up to subscribing, right? And let's just print this out so we can see what we get. Boom. Okay, so that should, in theory, work, or would, again, if we were able to authenticate. So let's see what we get. Hopefully we won't get a stream of events.
That would be awkward.
Okay, so this is very awkward here because Josh has locked himself out. Let's see. But intentionally, this is the part we're expecting to see, and then we're rewarded for our efforts. Josh has forbidden himself access to the system, probably because you've too much binge watching, right?
Right.
Okay, so let's try something different. Let's put our friend Rob in here, and of course Rob should have unfettered access, right?
To the whole system.
Everything. It's God mode. All right, so look at that.
Hey.
Look at that. All right. So you want to do a quick recap? And then we'll go out for that latte over.
Yeah.
All right.
Well, so what do? We started from the bottom, and now we're here.
The end. The end. Thanks for coming.
To paraphrase a great Canadian rapper. We started this journey looking at the Reactor project and looking at how to compose and build pipelines and how to use those basic primitives to describe compositions of data. But that isn't enough in of itself, as we saw. So then we looked at how to do data access using the MongoDB reactive integration, the Spring Data MongoDB reactive support. And this is very important, right? All kidding aside, it's very cool that MongoDB supports reactivity. It's very cool that these other drivers like Cassandra and Redis are reactive as well, because they have to do a lot of engineering work to make that work. This is something that bubbles all the way down to the database tier itself. The driver and the database have to work in unison for this to be effective. It's not valuable if at any layer we have a blocking call. So it's very, very useful, very convenient, very nice that these database vendors have taken the initiative to make their database technologies support what we're trying to do here. It's not an easy road to travel. So good for them on that. Then we took advantage of that. We connected our application to the database and we built a web tier. We looked at using this traditional Spring MVC style endpoints, right? And we established that while we have a lot of familiarity, while what we're doing is very familiar and very consistent with what you may know from Spring MVC, it is not Spring MVC, right? It is a brand new runtime. It is a brand new API. And the things that you would have done before in a synchronous world are not meant to work here, right? That's not going to serve you well to just copy and paste code into this new world. It's cognitively less expensive to understand what we're doing by using the Spring MVC style REST controllers, but this is not meant to be a way to sort of forklift code from that world to this. This is a a different runtime and a different paradigm. And the runtime semantics are going to be different as well, right? So it's worth keeping that in mind. That said, you do have the ability to run the sort of web frameworks, WebFlux and the functional reactive endpoints on traditional servlet endpoints and traditional servlet application servers, giving you unbounded portability for a otherwise very new sort of runtime, a reactive component model. Then we looked at functional reactive endpoints, and then we looked at how to secure the application using Spring Security, and then we looked at how to build a client. And we looked at the web client here, which is sort of an alternative to the REST template, the venerable REST template. This web client is, I think if you've ever used the REST template, this is going to feel very, very different from anything you've become accustomed to in the REST template. And that's for a number of different reasons, not the least of which is that the REST template, of course, is now more than 10 years old. It has done a very good job. It served us very well, but it was not designed for a reactive world, right? So a redesign was in order. And this gives us that. If you look at what we're doing here in the server side and on the client, we're dealing with unlimited amounts of data. We use, for example, we use the publisher that produces movie events. That publisher that produces movie events, we emitted those as a server-side event stream, right? A different content type that the client knew what to do with. That server-side event stream is not the same as a regular REST document, a regular JSON, application JSON or XML document. If you had tried to do the same thing with Spring MVC, you would have had to do a fair bit of gymnastics to sort of teach Spring MVC to use an SSE emitter to then, in a separate thread, emit the values and so on. You could do it, but it's very definitely going against the grain. It's more elaborate, more setup, more ceremony to get that result. By default, everything is a asynchronous publisher in this new world, right? So we wanted to do a single document. We just return a publisher. We wanted to return a potentially unlimited stream of data as a service-side event stream. Again, we just return a publisher, right? We get that benefit because it's reactive from the ground up. And the same is true on the client. We have a fully reactive client as well. So this is not the same as before. It should be approachable, but it's not the same thing. Keep that in mind. And this is just the beginning. Everything we've shown you is already, you saw this is all live. It's all stuff you can play with right now and use. There's a lot of other stuff that we could have shown you. We wish we had more time. We wish we could go for another 2 hours. But there's a lot of other stuff we could have shown you. For example, the native Kotlin support in Spring 5 surfaces a lot of nice DSLs that we have. For example, those functional reactive endpoints are really concisely written using the Kotlin DSL in Spring 5. In Spring Framework 5, there's a Kotlin module, right? Kotlin support. And so that's certainly something worth considering. And then, of course, going forward, Spring Boot 2 will serve as the baseline for Spring Cloud Finchley, which is going to be due next quarter, first quarter of 2018. And Spring Cloud has a new technology called Spring Cloud Gateway. And Spring Cloud Gateway is a Zool sort of microproxy replacement API, right? And it is a Spring 5 baseline technology. It's a brand new project that we're debuting entirely on Spring 5 and the reactive support here. So there's a lot of interesting stuff that's coming as well, but it all starts here. It all starts with start.spring.io. So, my friends, if you have any questions, we're happy to take them. Thanks, Mark.
Thank you. Fun.
Thank you, everybody. Yes?
Is that the WebSphere guy?
You get a list of fluxes and it's empty. Does that list have no fluxes to give?
Oh.
Right.
You're gone and done, fluxed up now.
Yeah.
Oh, for flux's sake. Oh. Huh? For what? Wait.
I just mean in general. You've got just traditional microservice setup. You said rewrite it in reactive, not for streaming, but for traditional data access to choose the reactive APIs. Like, how much faster is it under, say, high scale, for instance?
We didn't talk about that really.
It's not really a factor of faster. In fact, in some use cases, it will be slower. The difference is that you're managing scalability. You're managing scale a lot better. You're more efficiently using more of your resources. What am I trying to say? You're using more of your resources more efficiently. So you're not sitting and blocking. So do you want to add to that?
No, that's basically that, right?
Yeah, I mean,
oh,
yeah, that's a concise way to put it.
More responsive too. So one of the ways that I look at it is, imagine you have a traditional web app with a thread pool. Let's just say there's 2 threads in the thread pool. Obviously there's more, but it's easier to realize this example. And you have some requests that are taking a millisecond to complete. You know, they're fast requests, but some requests, if you have a slow client, they're taking 10 minutes to complete. You have 2 slow requests coming as blocking your thread pool. You got to wait 10 minutes for all those ones that are taking 2 milliseconds, right? So it's not responsive, it'll time out. Your connection won't even complete. Whereas with a reactive app, you can't block on a request thread. And so those 10-minute ones will still take 10 minutes, but the ones that are taking a millisecond will still get processed because that thread was not blocked. Does that make sense?
yeah. Good question. I wish we had addressed that up front. Other questions? You must have some.
What's a sync in your example that you were generating events?
You mean the one that didn't work? Thanks for bringing it up. Sensitive Claude, my heart. Let me see. That sync is a synchronous sync. It's where you emit the next value. It's the thing that you use to produce the next value that the publisher will then return or emit. Yeah, good question. Great question. Oh, we got to figure out why that didn't work.
We'll be on it
Oh, yeah.
later on over a latte.
Asynchronous.
Hint, 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 hint.
Other questions? Comments? Do you see things that that seem interesting to you here? Show of hands. Good stuff. Are any of you building services that are just running too fast and this is just not for you? Yeah. Okay. You're just not interested in handling any more users. If that's okay, and that's okay, by the way. All the old stuff's still there, still works, not going to go away.
Yep.
But
Well,
It was pretty opinionated on a lot of stuff, which I like. I didn't see you do anything about JSON, right? It just assumes JSON output, it serializes everything.
well, the client, yeah, we could do XML and so on, but you know.
But it's opinionated about a lot of things that are pretty common about HTTP and JSON and all that stuff. So I like that. Obviously, you guys have done this and you're moving quicker, but I like that from a configuration point of view. You were just focused on your left story and your application and only configure all that who's just there, right?
Yep. That's Spring Boot, right? So that's Spring Boot. Yeah, great point.
The starter is a quick way to get going. Right? I mean, we talk a lot about it. Myself, just getting guys in business logic, getting back to core mission, and so I like how.
Such a nice place to be.
yes. Yeah, we try. I'm not sure if I mentioned this earlier. I love the quote about undifferentiated heavy lifting. You know, that gains you nothing. And if you can leverage work that's already been done for you, opinions that have been logically made, rationally made, based upon that 80 to 90% use case to get you focused fast on the business differentiation, that's where all of us want to be. I mean, that's where the value is. That's where the, I hate to say fun is, but that's certainly where the rewarding part of our positions, our occupations are, is creating business value. It's not recreating the wheel. So yeah, there are ways to do all of those other things when you have to dive below the surface and get out of that 80 to 90% use case. But by and large, if you're within those 8 to 9 out of 10 times, it should be fairly quick to get out of the way and do what you need to do. So, yep.
What happens if you have to make a blocking call? How do you deal with that kind of situation?
If you what, I'm sorry?
You have to make a blocking call.
Oh.
On your APIs.
Well, you can do it. It's just one of those things that anytime you see the word block pop up in your code, that's probably a really good red flag to consider how you're approaching that particular problem.
Yo.
Oh, yeah, go ahead.
So there are situations where you're blocking or you are basically consuming CPU for too long period of time. So one example is actually in security. If you've configured security correctly,
Well, thanks for coming out. I mean, as Josh frequently says, you could have been anywhere, but you're here with us, and we really appreciate it. So thanks for coming, and thanks for inviting us. If you do think of anything else, ping us.
Especially movie titles.
We're on the interwebs. Yes, especially movie titles. So thanks.